A cooler has 24 bottles in it. You reach in and randomly pick a bottle. You give this bottle to your friend. Then you reach in and randomly pick another bottle for yourself. So right there, guys, they're implying order. The first bottle you pick, your friend gets. The second bottle you pick, you get to keep it. In the cooler, there are 3 bottles of Diet Coke, 10 bottles of Sprite, 4 bottles of water, and the rest are Dr. Pepper. So the very first move we have to make is we got to figure out how many Dr. Peppers there are. Well, we can figure that out because if we know there's 24 bottles and there's 3 Diet Coke and 10 Sprite, that's 13, right? And then 4 bottles of water, 17, so there's 7. Is that okay? There's 7 Dr. Peppers. Basically, what's our missing link to get to 24? Okay? So, on all of these, since we're picking 2 bottles, we're going to have 2 probabilities multiplied back to back, all right? So let's just do a couple of them. What's the probability that your friend gets a Diet Coke and then you get a Dr. Pepper? So a probability of a Diet Coke and then a Dr. Pepper. So I just asked you, how many total bottles do we have to choose from initially from the cooler? 24. Is everyone okay with that? And we are worried about getting a Diet Coke first. So how many Diet Cokes are there to pull? 3. Now that we pulled that Diet Coke, how many bottles are there? 23. And how many of them are Dr. Peppers? 7. So then you would multiply those. Is that okay if we don't worry about multiplying them? I just want to get the setup, okay, because this won't be for a grade. Let's do number 2 real quick. And we don't have to do all these, but I kind of like to play around with them. The probability that you both get Sprites. So they'll say that. What's the probability you both get Sprites or all 3 are Sprites? Think of that. Both Sprites means there's 2 probabilities. Or all 3, that means there's 3 probabilities. So how many total bottles are there to choose from? 24. And how many are there Sprites in the beginning? 10. But then we hand that to our friend. So what's the probability that we choose a Sprite? You see what's happening? Every time you choose a bottle, your denominator will go down. But if you're choosing the same thing back to back, your numerator will go down as well. 3, they try to just switch it up on you. What's the probability that you both have sodas? Well, do you guys agree that it's going to be 24, 23 on the bottom? Like, we don't even have to think about that now. And then how many sodas are there? Well, you go back to the top. Everything's a soda except for the 4 waters. So how many total sodas are there to choose from? 20. And you hand that soda to your friend. So how many sodas are there to choose for you? 19. Okay, so they'll just kind of like change how they ask it. Let's do 4. You guys are getting this, so I'm going to kind of go on a roll. Is that okay if I keep going? 4. The probability you get a water and your friend gets a soda, watch. It doesn't necessarily make a difference, but I do like to think about that order. Your friend is who we're worried about getting it first. So really you want to get a soda first and then a water. Okay? So the denominators we know are going to be 24 and then 23. But how many sodas were there? We just talked about it. There was 20 sodas, right? So you give that soda to your friend, but then how many waters remain for you? All 4 of them. Because we didn't get a water, we got a soda for our friend. Number 5. Neither of you gets a soda. No sodas. Again, I'm picking 2 sodas, so I know my denominator is going to be 23 and then, or excuse me, I'm picking 2 bottles, so I know my denominator is going to be 24 and then 23. Okay, well, we kind of just talked about this, guys. Of all the 24 bottles, 20 of them were sodas, so how many aren't sodas? 4. So, aka no sodas means we're both getting waters, right? So how many non-sodas? There's 4, but then I don't want a soda either, so how many does that leave? 3. All right, these are the ones I really want to do. What do you notice? At least one. At least one. Okay, so let's write this. I think out of anything, if you don't write anything but you just are showing me the probabilities, that will get you really, really far. But with these at least ones, I really think it makes a difference if you can write it. So the probability at least 1 is a soda. At least 1 soda. All right, we can handle this. At least 1 means what do I need? 1 minus the probability of, what's the opposite of at least 1 getting a soda? None of us get sodas. No sodas. All right? Why is this a little bit different than the worksheet that we just did? The worksheet we just did were all independent, so we could just put like 0.73 to the second or whatever. On this one, we still have to think that we're drawing 2 sodas, so we still have to do like this little mini thing down here, okay? So the no sodas is actually right here. It's the opposite of this, but I want to show you how we would set it up, assuming we hadn't done that yet, okay? The 1 minus hangs out, and you say, okay, well, how many people am I pulling bottles for? 2 of us, right? So I'm going to have 2 probabilities there. Or to have the second power if it was a percentage. What's the odds of picking a bottle? 24. Once I pick that first bottle, there's 23. And then just do your mini no sodas right there. How many are not sodas? 4. And how many are remain? 3. So notice it's kind of like what we did before with 1 minus, but instead of being able to raise 1% to a power, you do your little scenario of just that. If you just focus on that, and then don't forget the 1 minus is in front of it. Okay, so let's do this last one to see if we really get it. At least one of you gets the Dr. Pepper. So the probability at least 1 Dr. Pepper. DP. That's my favorite. Anybody else Dr. Pepper would be favorite in this cooler? What do you guys like? Diet Cokes or Sprites? Sprite. Really? And you don't drink, what, would you take a water, Jake?
Yeah.
Okay. Anybody a Diet Coke person? Yeah. I really like the orange soda and stuff like that, but okay. Mountain Dews, anybody? Okay, we're off track. At least 1 Dr. Pepper is 1 minus the probability that no one gets a Dr. Pepper. Okay, we got a little bit of thinking to do. Who's going to hang out with us? The 1 minus. How many bottles are we pulling from the cooler? 2. So I'm going to have 24 and 23 there. Is that okay? And I'm just going to focus on this. The probability of not getting Dr. Pepper. Well, how many bottles are in there that aren't Dr. Peppers? How many? 17. Are we okay with that? Because there were 7 Dr. Peppers. So that means there's 17 that aren't Dr. Peppers. And once I pull that and give that to my friend, how many remain that are still not Dr. Peppers? You guys rule. You guys get it.